Greeting to everyone. My name is Alan Castillo Alonso. I am a student of the Universidad Autónoma de San Luis Potosí. The subject of my presentation is synthesis and characterization of mesoporous silica nanoparticle. Introduction. Mesoporous nanoparticles are investigations for their physical, chemical, and biological properties, their surface fluctuation, their ability to contain, transport, and release active biologic substances against a stimulus for which they have received attention in areas such as catalysis, adsorption, separation, chromatography, chemical sensor, biosciences, therapies, oncology, biomedicine, and biotechnology. The size can vary from 25 to 20,000 nanometers. Previous test. This table shows the performance of previous tests. The purpose is to be able to achieve the adequate preparation and achieve the desired size of mesoporous nanoparticle. After 8 tests where age of the reagent was varied and their size was modified. With this 9 is where the objective was achieved and with which was advanced in the experiment part. Silica nanoparticle synthesis. To prepare mesoporous nanoparticle, it was done by the stop process, where ethanol, water, and ammonium hydroxide were added in a beaker, stirred on a plate. Theos was added with a peristaltic pump, obtaining a white mixture, centrifuged until a white powder was obtained. Finally, the powder is washed with deionized water. Repeat the process 3 times in order to remove the Theus precursor. At the end of the washing of the nanoparticle, the powder is then allowed to dry for 20 hours at room temperature. The inside mixture is analyzed by DLS obtaining the size and size potential of the particle, which must be between 95 to 1085 nanometer and -30 to -45 millivolts. The latest result in the measurement obtained by means of the DLS, it can be denoted that the size of the nanoparticle is 1002.5 nanometers, begins 1000% of tin. In the same way the size potential was measured, result in -30.3 millivolts, begins in the necessary range to be considered mesoporous nanoparticle. Preparation. For the preparation of sodium amoxicillin, 1 gram of amoxicillin was weighed to 10, preparing a solution with 15 milliliters of water, 10 milliliters of glacial acetic acid, and the full gram of amoxicillin. The solution is placed on a plate for 30 minutes. After time, it is removed from the plate and a density of 4,000 micrograms per milliliter. UVB's result. We continue to measure its absorption spectrum by UVBs of the amoxicillin solution, result in the maximum of the curve corresponding to 2085 nanometer of its wavelength of the density of 4,000 micrograms per milliliter of the solution. Comparative graph. Dilution were prepared using amoxicillin at 4,000 micrograms per milliliter, where 1 milliliter of the amoxicillin solution was taken with 1 milliliter of glacial acetic acid, diluting the density to 2,000 micrograms per milliliter. This was repeated until achieved a solution of 12.5 microgram per milliliter. Manganese 2 did not have its plasma decrease in each dilution. Preparation of amoxicillin with silica. In the case 0.00278 grams of silica powder were weighed to prepare a solution with 10 milliliters of amoxicillin and 5 milliliters of water in a beaker. The next step was to place the mixture on plate for 70 minutes. After time it is observed that it has not floculated. In the graph it is observed that when mixing the solution, two curves with different maxima are created. One corresponds to amoxicillin with its wavelength of 200 nanometers. The other curve belongs to silica with 360 nanometers, observing that the mixture of the reagent was successful. For the release of the reagent, dialysis membrane was used with the amoxicillin reagent and mesoporous silica nanoparticle. First, 15 milliliters placed inside the membrane. The next step was to place the membrane in a container with 225 milliliters of deionized water and leave it in for 44 hours at room temperature. A small sample of the liquid is removed and its plasma was measured with UV beams, denoting that if drug was released in the medium, signs different from those correspond to weather. For the bactericidal test, solution of disodium phosphate monopotassium phosphate Mueller-Hinton broth were first prepared for a total of 6 Petri dishes. A small portion of the bacteria was taken and plated petri dishes. After 24 hours, observing that E. coli and F. coli microdilution cells are used, placing 50 microliters of amoxicillin with mesoporous silica from column 1 and 2 in the well of column 2 to 12 broth of cultivation. The table summarizes the result obtained from the bactericidal test of 3 different solutions where it is denoted in which one of the microdilution cell bacteria grew and in which they were inhibited. Observing the cell and petri dish, the following was to calculate the concentration of each of them, obtaining different values depending on the solution and the bacteria.